and welcome. My name is Aurelia and today we are going to be discussing the greenhouse effect. But before we dive into the wonders of science, I would first like to ask you all a question.
Which of the below is the best definition of a greenhouse gas? A gas in the atmosphere that absorbs infrared radiation, a gas in the atmosphere that absorbs ultraviolet radiation, a gas in the atmosphere that causes rain to become acidic, or a gas in the atmosphere that is produced as plants grow?
The correct answer is a gas in the atmosphere that absorbs infrared radiation. Next, let's look at a textbook definition of the greenhouse effect. The dictionary defines it as such: warming of the surface and lower atmosphere of a planet that is caused by conversion of solar radiation into heat in a process involving selective transmission of shortwave solar radiation by the atmosphere, its absorption by the planet's surface, and re-radiation as infrared, which is absorbed and partly re-radiated back to the surface by atmospheric gases. Whew, that's a mouthful. So what does this all mean? The sun is drawn in yellow with the earth drawn in blue, and the sun radiates heat towards the earth. Next, I'm drawing the earth surrounded by the atmosphere. And so the sun emits what we call a shortwave solar radiation, and this heats up the atmosphere and the earth. Then the earth emits outgoing long-wave radiation, and this gets trapped in the atmosphere by greenhouse gases. So how do we even know which atmospheric gases are even considered greenhouse gases? Well, for starters, there's water vapor, methane, ozone, nitrous oxide, and carbon dioxide. So at this point you may be asking yourself, how do we even know these cause warming? This point will be best explained through an experiment. In this experiment, we'll be testing the greenhouse effect. And the materials you will need are as follows: 2 thermometers, 4 Alka-Seltzer tablets, 1 straw, an empty 2-liter bottle, some soil, scissors, the top of the 2-liter bottle, an empty container about this size, some form of a stopwatch, and a notebook to record the temperature readings. First, you will cut the top off of the 2-liter bottle so it may fit in the microwave. Next, fill it up with soil about this much. Then poke a hole in the bottle about halfway down so it may fit the straw. In the other empty container, poke a hole near the top so it may fit the straw as well. Then fill it up about halfway with water. Connect the straw into this side of the container. Take a measurement of the temperature reading in the room. It is currently about 68 degrees Fahrenheit in the room. Then put the 2-liter bottle in the microwave for 15 to 17 seconds. Once the bottle is heated, connect it to the other end of the straw. Put the thermometer in the soil. Put the top on and start your timer for 1 minute. Once you've let the temperature rise for about 1 minute or stabilize, take a reading of the temperature. It is currently about 76 degrees in the bottle. The soil that was heated from the microwave acts as the earth, and the heat is radiating, causing the temperature to rise. Next, we will simulate the greenhouse gas effect. Take the top off, and then take the top off of this container. Quickly put in the 4 tablets into the container with the water. When you put the tablets in, put the top on as quickly as possible. When the Alka-Seltzer tablets react with the water, it will reduce carbon dioxide. The carbon dioxide will be funneled through the straw into the other container, and then we will take another measurement of the inside of the container in about another minute. Start your timer. Once another minute has passed, let's take a look at the temperature inside the bottle again. and is currently about 86 degrees Fahrenheit. From this experiment, you can deduce that carbon dioxide traps the heat and causes the temperature to rise as well. That is a great experiment that you can conduct yourself at home. So now we know for certain that greenhouse gases do indeed cause warming, and that carbon dioxide is a greenhouse gas. The carbon dioxide traps heat near the surface and causes the temperature to rise. And as of March 2015, the current CO2 levels in the atmosphere are at about 400 parts per million. That's 122 parts per million more than the Industrial Revolution. How does this compare to the past? Let's take a look at a graph.
The graph shows the CO2 concentration in parts per million over 800,000 years. It was provided by iScore data. As you can see, the CO2 naturally oscillates between relatively high amounts and relatively low amounts. The present-day amounts are in the right-hand corner.
We can see that the present-day amounts are the highest in 800,000 years. How has this affected our global temperatures thus far? Let's take a look at another graph produced by the National Climatic Data Center.
This graph shows global land and ocean temperature anomalies from about 1880 to present day. The blue color indicates cooler than normal temperatures, while the red indicates warmer than normal temperatures.
So, since about the 1950s, the global average temperature was above normal and increasing in magnitude. In fact, the 5 warmest years on record are 2013, 1998, 2005, 2010, and the warmest year on record being 2014. At this point, you might be asking yourself, big deal, it'll get warmer, so I'll just, turn on my fan and turn down the air conditioner. So what? Well, climate change is actually a lot more than just increasing temperatures. In fact, in the United States alone, the Intergovernmental Panel on Climate Change, or the IPCC, report states that we could experience an increase in heat waves, droughts, and extreme precipitation events. These sort of events harm our properties, our crops, our economy, and sometimes our lives. Now what? What is there to be done? I don't know, maybe that's none of my business. In the meantime, we could work on reducing our carbon emissions because the United States happens to be one of the leading countries in carbon emissions. So some of the things that we could do would be to turn off the lights when they're not in use. I kind of need those.
Unplugging items when they're not in use. Turn down your thermostat a couple degrees.
Other ways to help reduce your carbon emissions and to help you save a little bit of money too would be to use energy efficient light bulbs. You could travel via public transportation. You could use your bike to get around. You could hang your clothes up to dry rather than using the dryer. And in the future, if you have the means to, you can invest in an electric car, solar panels, or insulate your home better. Unfortunately, for the time being, most of the electricity in the United States is generated by fossil fuels. Luckily, engineers are working on improving our technology for renewable resources, such as hydropower, solar power, and wind power. There are many ways to combat what lies ahead, and we can't keep saying, "I'll do it tomorrow." It's our future.